Hello and welcome to this presentation on the NCC 2022 Condensation Management Provisions. I'm Mark Davis, your host. Before we begin, I'd like to take a moment to acknowledge the traditional custodians of the land on which we are each participating in this presentation. In my case, this is the Ngunnawal and Ngambri people of the Canberra region. I would like to pay my respects to elders and extend that respect to Aboriginal and Torres Strait Islander people here today. Today's presenter is Heather Nielsen. Heather is one of the education team members here at the Australian Building Codes Board. Her work involves managing the development of education and guidance materials to support the recent changes to the code. Before we hand over to Heather, let's cover off the learning outcomes for this presentation. After this session, the aim is that you'll have a better understanding of the NCC and learn the following. First, be able to describe the changes to the NCC 2022 related to condensation management. Then be able to interpret and understand some of these provisions. And lastly, identify when these provisions will be adopted. Now I'll hand you over to Heather.
Today I will provide a summary of the recently released condensation management provisions included in the 2022 update of the NCC. These changes apply to a Class 1 building, a sole occupancy unit of a Class 2 building, or a Class 4 part of a building. The intent is to provide information on the provisions that will assist you in understanding the changes. Here is what we will cover today. Following an overview of the changes and their intent, we will look at the mandatory performance requirements. We will then look in detail at the key changes for condensation management. I will conclude by providing the information on when the changes will be adopted and where further guidance can be found. Okay, to begin with, I will cover the key changes that we think you need to be aware of. There are 5 key things to highlight in relation to the condensation management changes for a Class 1 building and a sole occupancy unit of a Class 2 building or a Class 4 part of a building. I will go through each of these in more detail as we progress through the presentation. Firstly, there is an extensive change to the clause numbering system. Second, there are changes to the deemed to satisfy provisions for condensation management in walls. Third, there are changes to the deemed to satisfy provisions for condensation management related to ventilation. Fourth, there are changes to the verification methods for condensation management F8 V1 and H4 V5. Lastly, related to the condensation management requirements, there are changes to the verification method for building envelope sealing, located with the energy efficiency requirements. Okay, so first, what is condensation and why is it such a nuisance? Condensation occurs when moist air comes in contact with surfaces at a lower temperature. It's quite common on windows on a relatively cold day or in areas with high moisture, such as in a bathroom, laundry or kitchen. It's important to distinguish between condensation and a condensation problem. Condensation becomes a problem when it doesn't fully dry out. Without adequate drying measures in place, water vapour can become trapped inside a wall or roof space and cause elements of construction to remain persistently wet. With enough time, you start to see mould growing on surfaces and some building elements starting to degrade, making the house potentially uninhabitable. So the most important takeaway from this slide is that condensation by itself is not a problem. It is an inevitable consequence of a combination of factors, including the environment, construction type, and occupant behaviour. Condensation becomes a problem when there is a lack of drying. If we think about this in relation to the updates to the condensation management requirements, what are we aiming to achieve? The simple answer is to avoid or minimise the risks that I spoke of in the previous slide, such as mould growth and building degradation. The risk which has the greatest consequence to health is mould growth resulting from condensation. Mould growth has been linked to serious respiratory illnesses and asthma in building occupants, and hence it's crucial to minimise this risk. The second primary reason is because condensation and the resulting mould growth could also degrade building elements and may need to be replaced in the future if the structure becomes unsafe. What you see in the image here are a few timber elements rotting in the roof structure. Regulating condensation is also linked to a range of secondary benefits. Some are listed here, such as air quality and energy efficiency. This means the provisions, which primarily focus on mitigating mould growth, could also improve the overall air quality and the energy efficiency of the building. It's also worthwhile noting, while the intent of these requirements is to assist in the mitigation of condensation within a building, these measures may not prevent condensation from occurring. This goes back to my previous differentiation between condensation and a condensation problem. Before we get into the detail, let's talk through the mandatory requirements, which are the performance requirements for condensation and water vapour management. The performance requirement for condensation and water vapour management in NCC 2022 has not changed compared to NCC 2019. In NCC 2022, it is known as F8P1 in NCC Volume 1 and H4P7 in NCC Volume 2. Both NCC volumes have the same performance requirement, which states risks associated with water vapour and condensation must be managed to minimise their impact on the health of occupants. Here it's worthwhile highlighting again that the NCC provisions only apply to residential buildings, which means a Class 1, a sole occupancy unit of a Class 2 building or a Class 4 part of a building. These mostly include houses, townhouses and individual apartments. Okay, so what compliance options are available for condensation management? One thing that is unchanged are the compliance pathways. Just as in 2019, you can demonstrate that a project satisfies the performance requirements using a performance solution, a deemed to satisfy solution, or a combination of both. You should note, verification methods are tests or calculations prescribing a way to comply with the performance requirements. They take several forms, including a test, inspection, calculation, or a combination of these. Option 1 on the left of the flowchart in blue outlines the elemental provisions that together form a deemed to satisfy solution. The relevant clause references are outlined for NCC Volume 1 and NCC Volume 2, and we'll discuss these further soon. Option 2 on the right of the flowchart in purple outlines the relevant verification method, verification of condensation management, and where it is located in NCC Volumes 1 and 2. We'll discuss this verification method later on in this presentation, as well as a related verification method for building envelope sealing that's located in the energy efficiency sections of the code. Okay, I'll go through the key changes to condensation management in more detail now. The first key change is the updates to the clause numbering that has occurred throughout the entire NCC. It is referred to as SPTC, which reflects the new system's referencing syntax, section, part, type, clause. Importantly, SPTC retains as much of the previous NCC's referencing system as possible. To assist practitioners transition to the new referencing system, NCC 2022 includes NCC 2019 numbering alongside the new numbering. For NCC 2022 Volume 1, you'll find the condensation management requirements in Section F, Part F8. Here you'll find the performance requirement, the deemed to satisfy provisions, as well as the verification method. For Volume 2, it's now located in Section H, Part H4. The performance requirement for condensation management is H4P7. The verification method is also located in NCC Volume 2 at H4V5. The deemed to satisfy provisions, however, are now located in Part 10.8 of the ABCB Housing Provisions Standard. The first set of condensation changes relate to the deemed to satisfy provisions for external walls, which are located in F8D3 of NCC Volume 1 and 10.8.1 of the Housing Provisions Standard. As I said earlier, depending on the design of the wall and the type of materials used, moisture has the tendency to get trapped internally within the wall space. It was recognised there was a need for adequate vapour permeability of materials interstitially. This is to manage the flow of water vapour and drainage of accumulated condensate to a drainage point into the external wall. This is critical, especially in colder climate zones like climate zones 4 to 8. So for NCC 2019, where a pliable building membrane was installed, it needed to comply with Australian Standard 4200 Part 1 and be installed in accordance with Australian Standard 4200 Part 2. There were also requirements for pliable building membranes to be vapour permeable for climate zones 4 to 8 and for it to be located on the exterior side of the primary insulation layer of walls. A pliable building membrane is defined in the NCC as a water barrier as classified by Australian and New Zealand Standard 4200 Part 1. For NCC 2019, there were no permeability requirements for other materials that form the external envelope of a building. This has changed for NCC 2022. In addition to pliable building membranes, where a sarking type material or insulation layer is installed on the exterior side of the primary insulation layer of an external wall, both materials now need to be vapour permeable. In climate zones 6, 7 and 8, these layers are required to be at least as permeable as an Australian Standard 4200 Part 1 compliant Class 4 vapour control membrane. It needs to be highly vaporable permeable. In climate zones 4 and 5, these layers must at least be as permeable as a Class 3 vapour control membrane. This means it needs to be moderately vapour permeable. There are no vapour permeability requirements for climate zones 1 to 3. In addition, where a pliable building membrane is not installed in an external wall, the primary water control layer, which is the external cladding, must be separated from water-sensitive materials by a drained cavity. This requirement does not apply to single-skin masonry or single-skin concrete constructions. Let's pause for a moment and check in on how we're going with a quick knowledge check. What minimum vapour permeance class is required for pliable building membranes installed on the exterior side of the primary insulation layer in Climate Zone 4? Is it A, Class 4, B, Class 3, C, Class 2, or D, no requirement? The answer is B, Class 3. In NCC 2022 Volume 1, Clause F8D3, a pliable building membrane is required to have a vapour permeance equal to or greater than that of a Class 3 as per Australian Standard 4200 Part 1. Now, let's move on to the next key change, ventilation of exhaust systems. The second set of condensation changes relate to the ventilation and exhaust systems listed in F8D4 of NCC Volume 1 and 10.8.2 of the Housing Provision Standard. Earlier, I was talking about the need for building materials to be permeable to allow water vapour to flow through to avoid forming condensates. It's equally important for us to manage moisture or water vapour in occupancy areas. Proper ventilation in a house or a building is essential to condensation management in a building. Let's start with areas of extreme sources of internal moisture. These are areas where heated water is produced, which are kitchens, bathrooms and laundries. Note, most of the NCC measures are already common practice. NCC 2019 required an exhaust system installed in a kitchen, bathroom, sanitary compartment or laundry to have a certain flow rate to ensure it captures the moisture generated in those areas. For a bathroom or a sanitary compartment, the minimum requirement is 25 litres per second, whereas for a kitchen or laundry it is slightly higher at 40 litres per second. It also required exhaust gases from a kitchen to be discharged to outdoor air. NCC 2022 provisions for kitchens are similar, except they are expanded to kitchen range hoods, which need to be discharged to the outdoors. Recirculating range hoods, for example, don't do a good job at removing water vapour from the air. It just filters out the odours and the grease, and the air is simply returned back into the room with all the moisture. Replacing a circulating range hood with a ducted one helps fix that issue, as it removes the water vapour from cooking directly to the outdoors. Similarly, for a bathroom, sanitary compartment or a laundry, NCC 2019 required these to be ducted directly to outdoor air or to a ventilated roof space. NCC 2022 requires all these to be ducted directly to outdoor air. you can no longer have exhaust gases ducted to a ventilated roof space. Another change in NCC 2022 is with areas where you dry your clothes. For such areas, NCC 2022 requires a space to be provided for ducting from the clothes drying appliance to the outdoor air. If the room is not naturally ventilated in accordance with clause F6D7, it also needs to be provided with make-up air in accordance with Australian Standard 1668 Part 2. These requirements do not apply if you have a condensing type of dryer. A common reason for condensation problems in bathrooms or sanitary compartments is that the occupants do not turn on the exhaust systems. That's why for bathrooms or sanitary compartments that are not naturally ventilated in accordance with F6D7, or those that have exhaust systems that don't run continuously, NCC 2022 requires the exhaust system to be interlocked with the room's light switch. This means the exhaust system will turn on as soon as you switch on the lights. The code also now requires a run-on timer, so the exhaust system continues to operate for 10 minutes after the light switch is turned off. Another area of focus for the condensation management requirements are for roofs, and they are listed in clause F8D5 of NCC Volume 1 and clause 10.8.3 of the Housing Provisions Standard. Water vapour is lighter than air, so it tends to rise. Hence, roofs are also susceptible to condensation risks, especially in cooler climates. NCC 2022 requires roofs in climate zones 6, 7 and 8 to provide an escape path for water vapour in the form of a roof space. The roof space needs to be at least 20 mm in height and located immediately above the primary insulation layer, or immediately above sarking with a Class 4 vapour permeance above the primary insulation layer, or immediately above the ceiling insulation, which also meets some energy efficiency requirements for thermal bridging. Secondly, the roof space needs to be ventilated to outdoor air through evenly distributed openings. The ventilation opening details depend upon the roof pitch and the type of roof. The ventilation openings are not required for a roof space which is located immediately underneath an unsarked tiled roof. There are exemptions which apply to a concrete roof, a roof made from structural insulated panels, and a roof subject to BAL FZ requirements, which are the most onerous level of requirements for buildings located in a bushfire-prone area. Let's check in again on how we're going with another quick knowledge check. An exhaust system in an unventilated bathroom or sanitary compartment that is not run continuously must A. Discharge directly via a shaft or duct to outdoor air, B. Have a minimum flow rate of 25 litres per second, C. Be interlocked with the light switch and have a run-on timer, or D. All of the above. The answer is D. All of the above. All of these elements are needed for this scenario so the moist air can be discharged directly to the outdoors without needing to rely on occupant behaviour. Now let's look at the verification methods related to condensation management. The condensation management verification method is shown on the slide. In Volume 1 it is F8V1 and in Volume 2 it is H4V5. It is the same in Volumes 1 and 2, only the numbering is different. The verification method includes extra details compared to NCC 2019 to help practitioners complete their respective condensation risk analyses. The method now includes quantified targets for allowable condensation risk. The target is a mould index of less than or equal to 3, as defined in ERA DA07. ERA DA07 is the criteria for moisture control design analysis in buildings and is an NCC reference document. The mould index is simply a measure of mould growth potential. So to use this verification method to meet the performance requirement, you need a mould index of less than or equal to 3 on the interior surface of the water control layer, or the surfaces of the building fabric interior to the water control layer. The mould index can be determined using hygrothermal models, for example WUFI. The verification method also requires the calculation methods and input assumptions to be established in accordance with ERA DA07. The verification method is only applicable to roofs and external walls. There is another optional verification method relevant to condensation management, although it's located in the energy efficiency sections of the code. This verification method, which is H6V3 of NCC Volume 2 and J1V4 of NCC Volume 1, specifically applies to well-sealed buildings. This is because well-sealed buildings can have poor ventilation, which can lead to increased condensation risks. There is a potential that too much moisture is trapped internally with no escape routes. Having said that, buildings that are both well-sealed and adequately ventilated can be very effective at managing condensation. To use this verification method to meet the performance requirement, you first need to know the air permeability of the building. To do this, you need to undertake a blower door test. Should the resulting air permeability be less than or equal to 5 metres cubed per hour per metre squared at 50 pascals, the building must have a mechanical ventilation system that can be run continuously, or intermittently, where the system has controls that enable operation for not less than 25% of each 4-hour segment. In addition to continuous ventilation, extra ventilation openings for combustion appliances, such as gas and wood-fired heaters, are also needed. If you want to know more about what I have covered in this presentation, there are a few places you can visit. The ABCB Resource Library has lots of content to help you understand the NCC, be that existing content or the changes in this presentation. You can find the Resource Library on the ABCB website. Our resources include in-depth handbooks, helpful articles and calculators to provide further guidance when working with the NCC. It is worth acknowledging here that condensation is complex and needs to be managed in all phases of a building's life cycle, i.e. design, construction and occupancy. The NCC prescribes a minimum set of requirements, and the intent of these requirements is to assist in mitigating the risk of condensation within a building. Having said that, the implementation of a condensation management strategy may not prevent condensation from occurring. There may be a few more things you can do to manage that risk. The ABCB's Condensation in Buildings Handbook is a useful tool which introduces the concept of condensation and its causes and consequences if left unchecked. It also expands on the regulatory requirements of the NCC by providing non-mandatory guidance for designers, builders and occupants on potential management and communication strategies during various phases of design and construction. Another resource that you can access online is the Your Home Manual, published by the Department of Climate Change, Energy, the Environment and Water. Find it at yourhome.gov.au.
Thank you, Heather. If you want more information, visit abcb.gov.au.